In this video, I'll be covering problem number 6 on the test review. It says, Marcus is a farmer and needs to construct a pig pen along the side of his barn so the pigs can run and play. So you're definitely going to want to start by drawing some kind of picture. Say this is the barn, and you're going to build a pen along the side of it. So this is similar to the problem that we did in class. You're going to have a three-sided, or a fence, where you got to put up this fencing on 3 sides. It says the pen will be adjacent to the barn. Adjacent just means next to, so that the pigs can go from the barn to the pen, meaning this is basically what the picture looks like. He wants the pen to be rectangular with 3 sides made of fencing and the other side against the side of the barn. And he has 80 feet of fencing available. Just like we did in class, you're going to have 2 lengths. You've got this width and this length. These are going to add up to the perimeter of 80 feet. So if you think about the equation for perimeter here, that's adding up the sides, we're going to have 2w plus our length equal to 80 feet. Well, if twice our width we don't know, we should be able to create an equation or an expression for length. That expression, if you think about this right here, if we were to solve for length, you should agree that we would subtract 2w from both sides. So length would be 80 minus twice the width. Okay? So for part A, it says define a function a of x, so we're just going to use x instead of w for width, that describes the area of the playpen. Well, recall for a rectangle, area is simply length times our width. Well, which expression represents the length? That would be 80 minus 2x, and our width, of course, is just x. So this is our expression that defines the area of the playpen. This is acceptable, okay? So a of x equals, I'm just going to put the x in front because it's a monomial, 80 minus 2x. If you want to distribute it and put it in standard form, that's fine. You are going to, for part B, have to put it in standard form anyway. So, if part B says use your function to find the dimensions of the pen that has the largest area possible, we should recognize some things about this function that will help us to answer that question. This is our area function, width times length. If we were to distribute this, we end up with 80x minus 2x squared. We should recognize that this is in standard form or descending order, that we have a quadratic function with a negative leading coefficient. Oops, that has x. And with a constant term of 0, which means we know it goes through the y-axis at 0 and that it opens up, but comes back down. Okay, so I apologize, it opens down. Our job to find the maximum area is to find the max point. You may use your calculator to find that value, but you have to show the work that I'm getting ready to show you in order to receive credit. So that means we're going to take this equation that we've got here in standard form and complete the square with it. First step is to put parentheses around the quadratic and linear terms and factor out the a value, which is negative 2. When you divide both of these terms by negative 2, you get x squared minus 40x. So notice these are equivalent equations or functions at this time. To complete the square, we need to add in a value that will create a perfect square trinomial. So we need to add a blank here. But recall from earlier, if your leading coefficient is negative, you're always going to add at the end. The next step, we need to take half of b and square it. So half of 40 is 20. 20 squared is 400. Make sure that you recognize that you do not automatically add 400 here just because you added it here. If you were to distribute this, you would see that we really added in a negative 800 that was not there. So we need to counter that by putting plus 800. Bring down your a value and factor this, x minus 20 quantity squared, remember square root, keep the sign square root, plus 800. So this would be our function in vertex form. Why do we want vertex form? Because we can quickly identify the vertex as 20, 800, which means this point up here would be the width, because x is our width. So x is the appropriate width to get a max area of 800. So when it says use your function to find the dimensions, I need to see all of this work here. If visual is helpful, then feel free to draw a graph. But that means that the dimensions would be 20 by, so if our width is 20, our length, remember, is 80 minus 2 times W. So 80 minus 2 times 20 would give us 40. And that should make sense because our perimeter should add up to 80. So back to the picture, this side would be equal to 20, that side 20, and that side 40. So the dimensions would be 20 by 40 feet. The largest possible area is the K value in your vertex, which was the 800. So 800 square feet. Okay? In the next video, I'll be covering the problems with imaginary numbers.